Alright, so specific dynamic action. So this is another component of energy expenditure, and we get to see that it refers to the increased heat production after eating. So it is also called diet-induced thermogenesis, and then or postprandial thermogenesis. So postprandial, after eating, thermogenesis, heat energy generation. So diet-induced or postprandial. So we get to see that this SDA is believed to be due to energy expended in the digestion, absorption, transport, and subsequent processing of the food. So yeah, digestion, absorption, transport, and subsequent processing of the food. So originally it only referred to handling of proteins, but it has now been extended as an effect produced by the consumption of all dietary fuels. So the consumption of proteins does, however, produce the greatest loss of energy, where it has a 20 to 30% of the energy is taken there. And then if we compare that to fat, for fats it's like 11 to 13%, and then for carbohydrates just 5 to 6%. So these are the percentages of energy that are dedicated to each of these macronutrients upon them being absorbed, digested, transported, and processed. So passing through it again, 20% is going to the proteins, 11 to 13% is going to the fats, 5 to 6% is going to the carbohydrates. So relatively higher SDA of proteins is primarily to meet the energy requirements for oxidative deamination, synthesis of urea, and biosynthesis of proteins. So that's why the proteins generally have a higher percentage in this case. So we get to see that the SDA is a wasteful expenditure from a viewpoint of cellular energetics. Alright, so look at this. So for example, you have 100 grams of protein that you consume. So the energy available for doing useful work on this 100 grams, as we said before, for proteins is in between 20 to 30%. Which is in between the 20 to 30%. So calculating this can be as follows. So if a person takes up 250 grams of a protein, so we're going to notice that that 250 grams of a protein is going to overly produce 1000 kilocalories, because remember we said the energy released from breaking down one is what? 4 kilocalories. Was it 4 kilocalories? Okay, but yeah, it was 4 at that time when we were looking at those things. Yes, that was kilocalorie per gram, so that was 4. That was for proteins. So if we multiply the thing that we've taken in, which is the 250, multiply it by the 4, it's going to give us 1000 kilocalorie. So if we get this 1000 kilocalorie, and then let's say we get 20% of this kilocalorie is used up to actually absorb, digest, and utilize this protein. So we're going to find 20% of the 1000, which is going to be 200 kilocalorie to there. So the net value of 250 grams of the protein is 80, due to the fact that we're going to subtract that from that. So in a case of a mixed diet, the SDA is around 10%. So the percentage of energy lost being 10% of a person's food worth should obtain shan. So if a person takes up, so in a mixed diet, if a person takes up 110 kilocalories, they are generally going to intake this. Okay, so that's additional calories must be added during dietary planning to account for the SDA. So finally, SDA shows considerable individual variation and thus has been implicated as an important factor which allows some patients to maintain their normal body weight even after overeating, because they're going to have a high SDA which is going to get rid of that excess female. So the main high yield thing that you must get here is that the SDA can be seen from a viewpoint of cellular energetics or from a mixed diet. So when you're looking at a single diet containing only of here we talked of protein, so we talked of the 20 to 30%, and when we got the 20%, found 20% of what this person got, and we found the overall intake, which was 80 kilocalories. But in a mixed diet, just maintain the 10% of whatever intake the person has gotten, and then find 10% of that, and then do the subtraction, and that's what the person is actually going to have. So next up we have physical